What's happening, guys? Now, today's guest is a good friend of mine, and we're not here to talk about why we're friends. We're going to get deep into her studies. Now, this person has a passion for learning. That's resulted in a bachelor's in psychobiology, an honors, and a master's degree in brain and cognition in society, both obtained from the University of Amsterdam. Guys, I'm probably butchering this intro to this guest, but although her educational background is mainly centered around neuroscience, she has explored a variety of topics during her studies, ranging from chemistry, mathematics, programming, robotics, language, and music cognition, forensics, genetics and evolution, human and animal ethics, and neuromarketing. Presently, she works as a teaching assistant for the university alongside her full-time job in cheerleading. So that's where the link is, guys. But you can see her background is very interesting. We would normally come on and talk about her cheerleading background, but today I want to get into what she has studied in university. So welcome to the show, guys. Christine, I'm not even going to say her last name, Van Nooijen. I normally call her Van Noodle. So welcome to the show, Christine.
You say, goddamn. You said, all right. I said, let's do a podcast. Let's sit down. Let's get a coffee. Let's just talk about 1, 2, 3, 4. Coffee with the Sam. Got a little podcast. Grab yourself a little coffee and a podcast.
Oh, like, he's not now part of the CIA.
No.
Love a good conspiracy there.
A little bit of conspiracy theory, a little bit of flat earth.
Well, welcome to the show. It's taken a long time to get you on. Yeah.
We've been planning this forever.
Yeah, and apart from the problems today, we've had a couple of weeks of trying to get you on here. Just reading your bio, I probably butchered it massively. And just reading your bio made me feel dumb.
Nice.
So tell the viewers and the listeners just a little bit about yourself, because you'll probably sell yourself a lot better than I did.
I will do my best. So hello, my name is Christine Van Nooijen. I am 23. I just graduated, as I was just telling Sam, at the University of Amsterdam for my master's in Brain and Cognition in Society, which is a psychology track. Before that, I did a Bachelor of Science honors in Psychobiology. And I have a lot of different kind of directions that I went in during my studies. I love learning. I love learning new stuff. So beyond just the neuroscience that was basic for my course, I also did lots of like robotics, language and music. Some of the stuff that I did, I currently TA for as well. So I'm a teacher at the university now. Not full-time. Actually, my full-time work is with cheer, which is how I met and know Sam now. We both work for a future cheer together. And outside of that, yeah, that's kind of everything I do. I'm like Sam in the sense that I don't really have hobbies. I just have careers/work.
Yeah, we like to try and get paid for it. So yeah, you definitely did that a lot better than I did. Yeah, well, you sold it a lot better. I was probably getting some of the words wrong. I bailed on your last name. I said Christine, and I went to go in, and I was like, no, because I normally call you Van Noodleburger or Van Nooijen. Is Van Nooijen?
Nooijen would be like the English person trying to pronounce my last name standard.
Okay.
So that's what most people say. So like I respond to it now, but it's not right.
Yeah. So that's how much of a muppet I am. So just trying to read your words, like well, I think the first one was chemistry or biology, something like that, both together. And yeah, my brain just went, what? So let's get straight into it. And what I've learned quite a lot about the body, but stayed away from the brain because I don't want to get too deep into something that I really don't understand. So I don't want to pretend that I understand something when I don't understand it. So what is the brain? Like, I just see this mushy thing that's got a lot of electric in it, and like, yeah. So what is the brain?
That's pretty much it. Honestly, you've hit the nail on the head right there. It's this mushy thing with some electricity in it. Your brain is you. It's what you are experiencing right now. It's all of that. So it's you. You are a brain inside a bone, which is your skull, and a bunch of other stuff around that to protect it. But basically, it's what you are, and it makes up everything that we do. Everybody seems to be really interested in the brain. I've never had a conversation with someone and told them that I'm like into neuroscience and that's what I study, and they're like, oh, well, I don't really care. You know, like we have this inherent nature to care about it because it's our everyday experience. It's how we see, it's how we communicate. It's responsible for so much stuff, like so much of our emotions and things that we sometimes even don't understand. It's really hard to kind of put a finger on like how far it goes out because there's so much that falls under it. But in terms of like a physical perspective, like physically, it is just kind of this wet, mushy thing, which is, I don't know if you've ever, maybe because you've talked to Alex before, had experience with seeing like a real brain or holding a brain.
No.
You held a brain before? Has
No.
Alex held a brain before? Okay. So part of the anatomy classes that we have to do at the university is you have to go through and you have to, you know, hold all of the different body parts and sometimes almost piece them together like a puzzle just to figure out how all the connections and stuff work, especially when you're learning about the nervous system, about the organs and stuff like that. And holding a brain is a very strange experience in that sense, because you're like, oh my God, I have one of these. I am one of these.
I couldn't imagine. Yeah. It's pretty cool that I'm talking and I've met someone who's held a brain.
Yes. In my hands.
That's pretty cool.
Yeah.
Did you know the name of the person whose brain you were holding?
No, I mean, that's one of the things when you work with bodies, to put it blatantly, is that you don't usually have any information about that person's personal life. That's all very much protected. Like, obviously, you can see their face because you're working with their body, but any kind of identifying information is all really protected. And also, when you go in there, you're not allowed to like bring a phone or bring any kind of electronics in there, because obviously they've given the person has given consent for the scientists and the researchers to have access to their body, but not for, you know, the rest of the world to see it. So obviously you can imagine if you're on social media and you come across a post that has like your dead grandma in it, all of a sudden that's really jarring. So there's a lot of restrictions around that kind of stuff. Yeah.
I'm so childish. I'd be like, oh, I want to take pictures. I want to be sticking my fingers up my nose and like,
oh my God.
But then you would remember like, oh, wow, that's a person. Like,
yeah, it's really weird. And there's different things for different people that kind of set them off and that get that little, like that tick in your head from, oh, this is fun to, oh my God, this is a person. For me, it was when you see like the eyelashes and the eyebrow hair on someone's face. That was just I don't know why. I don't know what it was about that, but that was the moment for me that I was like, oh my God, like this is an actual human being. Like this is not just a piece of plastic. And you go very quickly from that, oh, this is fun, to, oh my God, you know, like all that existential doubt drops on you.
Yeah, you stop smiling and you start thinking, I need to take some care with this. Like, oh, wow.
Yeah, absolutely.
So how does a brain work?
Ooh, I mean.
Go deep. Remember, you're not just talking to me. Like, yeah, you know, when you talk to me, put it in simple terms. You're not just talking to me. You're talking, just talk how you would want to. How does a brain work?
I'll pick like little smaller subsections so that we're not going to the whole thing in one thing, because it does so much that it's easier to just start with. Like, for example, the brain has two halves. You probably know this as well. Like you have your right side of your brain and your left side of your brain. And these two halves, they connect to each other with a pathway called the corpus callosum. So because of that, your brain can communicate in its entirety. And then there's also 4 different lobes in your brain. So you have frontal, parietal is on top, and then temporal on the side, occipital on the back. Do you want to take a guess at what any of those do? Do you want me to just tell you?
Just tell me.
Okay. So we have occipital at the back. So that's the one at the back, down by the back of your neck almost. That's responsible for a lot of visual stuff. So a lot of what we see. And that's actually, it's organized pretty cool. We can get into that later, maybe a little bit about how we see and what visual processing looks like, because it is a really interesting subject. Then we have frontal up the front, which works on a lot of executive functions. So things like planning, decision-making, all that kind of stuff, setting goals, reaching goals, a lot of more control and what we would assume is kind of working memory, everyday kind of control tasks. Temporal on the side, which has, of course, it's by your ears, so it has a lot of your auditory processing in it, but it also has your hippocampus and a lot of other structures that are associated with memory. That's quite an important one. And then the last one is parietal up here, which has a lot of your motor functions. So if you're moving your body around, all of that is there as well. There's one little addition to that though, because a lot of our motor function is up here and a lot of our motor control, But then we also have this one little bit at the back, the cerebellum. It looks like this like weird, mushy, wrinkly little thing at the back of the brain. Looks a little bit like it stands out, looks a little bit odd. And that's for a lot of fine motor control. So if you do handwriting or if you play the piano or something like that, all that really fine control, that all comes from the back of your brain and not really as much from the top. So that's the 4 lobes. Then we have like the inside. So these 4 things are around like the inside, and the inside is where you have things like your basal ganglia, your brainstem. And this is kind of where a lot of your basic regulatory functions come in, like your amygdala. So that's like sleeping, breathing, your heartbeat, which are all good things to have in order. So it's a good thing they're on the inside and far away and protected from being damaged as well.
Do you think that's why it's there?
Well, it's there. We know this, like evolutionarily speaking, that it's in the middle because that's how our brain developed evolutionary over time.
Okay.
So like, for example, sometimes people refer to it as like your reptilian brain or something, because it's like, that's the structure that we have that's kind of central to it. And the outside layers, like the 4 different lobes, those are ones that developed a lot later on in our evolutionary pathway. So they kind of came on later, which is why they're like on the outside.
Do you think it could be there as well though? Because like, if we do get trauma to the head, all our body really doesn't care about playing the piano. It cares about just breathing and lying there. Like, it doesn't care if it can move, as long as it can just lie there and live.
Yeah.
Then that,
Sure.
So do you think that's why it could be so deep down inside because of that?
I think it might just be a nice little side effect, basically, of the way that it developed.
Yeah.
I mean, for us, it's really beneficial, of course, because those are like our central kind of things that we need as well, right?
Yeah.
But also for us in day-to-day life, things like your prefrontal cortex, frontal cortex are also going to be super, super important. Like if you're missing a large section of your brain up here, or really anywhere in your brain, you're going to have a lot of difficulty kind of like reintegrating back into society and all that kind of stuff, which is annoying.
Yeah, but for us that's annoying, but your body's just like, I want to be alive.
So all things considered, like if you just like the bare minimum really
all your body wants is that bit in the middle, because it can breathe and it can do its bodily functions. Like I said, it doesn't care about if I can talk to you or not, or if I play the piano.
So that depends on your perspective of what being alive is, which of course is a whole other philosophical discussion that we probably shouldn't get into.
But it's a bit like this. Is it the same sort of thing with the body when, I don't know, when it gets cold, it'll start to get rid of things like your arms and your legs, because your brain, which we're actually talking about now, is a bit like, well, I don't need those to survive because I can still breathe and all this is in my torso. So I'll just get rid of that, and I'll get rid of that and get rid of that. That's something I was thinking about. Is it in the middle, just like, because that's the bit I really want to look after.
Yeah, that's actually a really good point, because like, you know how we have a fight and flight response, that kind of thing, right?
Yeah.
That comes from our amygdala largely, and our like ACC and those circuits, which are part of that kind of emotional center right in the middle. And a lot of what happens there. So for example, if you are like really stressed about like taking an exam, or really stressed about a performance, maybe like a cheer performance, and you feel like you're starting to like block, like you can't even kind of think straight because you're just so worried. A lot of the time what happens there is that there's so much like energy and blood going to those emotional centers that a lot of the blood that would normally flow to the outside, where you have your planning and your rational thinking, that's not as much energy is going there, because it's all going to like this little fear hub in the middle. So that's one of the reasons that when you see, like, for example, kids who like block right before a skill and tumbling, or like when they take an exam at school and they're like, I don't know anything anymore, that's kind of where that comes from, right? Because there's like this deficiency here, because all of it is coming from this internal need to protect. Like, we need to protect ourselves, and we need to either run, which is not great in the context of an exam, or we need to like fight someone. Also not a great response to have, in all honesty. So that's what happens. Yeah.
Oh, that's cool. That's a good way to explain it, because I used to get that. Like, even I still get it before this stuff. I still I have to redo my show notes and stuff, because as soon as I go live, or as soon as I come on here, I'm like, boof. I could be really excited about a podcast, but I go, and obviously what's happening. It's getting to that, oh, well, this needs to be good, or this person's going to be on the other end of the line. It's got to be good. And I'll just start to panic a little bit. Whereas trying to calm myself down and relax, and that used to happen before cheer comps. I used to block so bad, and then in routines, as soon as the music started, you'd get a good 5 seconds, and I used to be flat and not knowing what was going on. And I've been known to do things on the floor.
Oh my God.
just stand still, because I just don't know what I'm doing. Literally, and that's obviously that's what's happened. But going up, and the things that we've done is I've learned to what do you do when you control that? What are you doing when you control that blood flow? to be able to keep it from going there? What are you doing?
Yeah, that's really difficult, right? Because I mean, the concept of controlling your blood flow is really difficult. And that's something that we're still looking into to an extent. Like, how do you deal with stress? And how do you deal with, like, you know, when people have chronic stress or PTSD, and those are the kinds of situations where these core regions are really being overstimulated and we're not getting enough to like the outside regions. It's kind of an ongoing debate. Personally, what I've done with a lot of my athletes who are like terrified of going and competing, that kind of stuff, it's the strategies that you use to either talk them out of it or distract them from it. So either you tell them like, oh, it's just adrenaline in your body, you know, like your body knows what to do. And then the distraction kind of like make them go over it in their head, make them visualize. I think the best kind of preventative tactic for it, especially when you're working with either sports or something that requires like a skill to carry out, something that you can practice, is just to practice it so much that you just get to the point of, okay, well, even if I don't really know what I'm doing, my muscle memory has got it, you know, like I can do this in my sleep, I can do this backwards with my eyes closed. When you're at that point, then you don't really have to worry about the adrenaline kicking in, because then it's already there, it's already set in your body.
And
So.
regarding what the brain is doing, what's the brain doing when we do that? We talk about this, getting these sports psychiatrists in and breathing techniques, and what's happening to the brain. So you've explained this blood flow going woof to this fear hub in the middle. What are we doing when we start doing this breathing, this the directional techniques of thinking of something else, of thinking while we've got it, like our body knows what it's doing. What's going on in our brains to bring that blood away from that fear hub, so the rest of the brain gets blood flow to be able to not panic and think about what we're doing? What's happening?
Yeah, so to kind of simplify it a little bit, like where we direct our attention is where our blood flow is going to go. And this is actually one of the techniques that they use for things like MRI, fMRI, is where which direction the blood flow is going in. That's kind of how we map which regions are active. So by that logic, then if you focus your attention on something that requires, you know, a different part of the brain, then you are kind of directing the blood to go there instead, which means that, you know, there's only a limited amount of blood in your body. So then you have to take it away from somewhere else, hopefully from the amygdala and those fear centers that are activated because of your fight and flight. And breathing helps with that as well, you know, like getting your heart rate down so it's not pumping the blood as hard through your body. All of that kind of works together. So if you, it can be hard, it can be really difficult to kind of try and put your mind into a different place, especially when you're so absorbed into it. But if you can figure out how to like take a couple deep breaths, you know, just take a step back, maybe think about something a little bit different, something that involves, you know, memory, something that's more on the side of your brain, or something that involves planning or goal setting, that can really be helpful to bring that down a little bit.
So that's why like the square box theory works. That simple one of going round the square box and counting and stuff, because you're using different
Counting
parts
is a
of the
good one.
brain.
Yeah.
So you're using complete different parts of the brain, and you're actually focusing on your breathing, which I take that's different part of the brain, right? Breathing to where the fear is. Cool. So we dive round that. So blood going to the brain, but how does the brain work?
How does it work?
So you've got blood there,
Mm-hmm.
but then how is it telling me to do this? How is it telling me to talk to you? How is it? What is that? What is it? What's happening?
I will say we probably won't be able to get too deep into it, because a lot of this is like, you learn something new in neuroscience and then you end up just with a question, okay, but why?
Yeah.
You know, and that it keeps on going indefinitely.
That's science,
and
right?
it's very easy to get to a point of, oh, we don't actually know. We have theories, but we don't actually know. I can tell you a lot about how like the structure works, like for example, how a neuron works, how neurons communicate with each other, that kind of stuff. But all of that is still relatively abstract compared to, okay, but how do we end up with a thought, you know?
Oh, that was one of my questions. That was literally one of my questions. We'll get to that. So, okay, you got blood flow, you got neurons. So that's your electricity, right?
Yeah, so the neurons work with electricity.
Yeah, go into your brain. Where are they coming from? Like, are they...
Okay. So let's say you have to have some kind of input in order for something to happen, right? So sensory input from your 5 senses can go into the brain. And then from there, you have like an action potential, and that causes like a neuron to fire. And the way neurons fire essentially is when they get some kind of like electricity input, when that's converted into electricity from some kind of sensory input, it will travel through the neuron down to the end of the neuron. And the end of that neuron will be connected with the beginning of either one or multiple, like maybe even 100 other neurons. And then depending on how strong that electricity signal is from the start of the neuron to the end of the neuron, that will depend on how many other neurons are then activated from there. So if you have like a really, really loud noise, for example, in your ear, that'll convert to a really strong, electrical signal, which will then likely reach the threshold to cause an action potential, and then reach the threshold for a number of other neurons as well. And that propagates in that way, which is, it sounds kind of simple and abstract, but that's what's going on basically, but like a million times over in your head.
Yeah, I was just about to say, like, it sounds, we are so complex, and I know you say like we don't actually know when you get deep right down to the bottom of these things, but like I'm trying, when you're speaking like that, I'm thinking of things that work like a light, like if a loud noise, or what we're doing now, like me talking to this microphone, which then turns it into signals and to be able to record it. I'm like, but then we're not plugged into anything. So how does the body, how?
Let's start with seeing stuff, because I think seeing stuff is an important one, right? Like, it's seeing stuff takes up so much of our brain. Like, I think more than half of our brain's capacity is dedicated to something that's visual. So visual starts on the occipital lobe, which is right at the back. And the way that it's built up is actually quite interesting. And we can tell the way that it's built up based from people who have like issues and lesions and problems with the back of their brain. So with the occipital lobe, you have a number of different areas. We call them like V1 through to V5. And they build up different aspects of what you can see. So for example, when you see something, we just view it as like, we can identify objects, right? We can identify, like, for example, I have a plant sitting across from me. I'm wearing a pair of glasses. We know what those objects are and where they begin and end. But when our visual cortex, how that works is we start with like dots and lines. So we have, for example, single cells, or at least we think that we have single cells that code for different like dots, for example. So points in space and what color they are. Like, for example, you might see here is like a pink point in space behind me. And then from there, you go up in the hierarchy, and then you go to lines. So now you can see horizontal lines, vertical lines, maybe lines at an angle. And then those neurons go up a hierarchy, and then you can start to see these basic shapes. So 2D basic shapes, like, you can see a square, a rectangle, a triangle, a circle. From there, you go even further up. Yeah, you get like, you start to get your color in V4 and V5, and you start to get your motion in as well. Motion is a big one. And from there, you have two pathways, one of which goes up, one of which goes across the side, which go into things like object recognition, identification, and then also control of spatial awareness. So for example, I know that this is a pen when I hold it like this, but I also know that it's a pen when I hold it like this. So that's something that goes up more along the top here in the pathway. And it's really interesting because you get to see a lot of different, you come into contact with a lot of different issues where people have damage to certain parts of the brain. And because of that, lose certain little bits of this process. So for example, there's some people who can't see motion. So they can only they see the world basically in like static pictures that switch every second or so. And it's a really difficult thing for us to kind of conceptualize, right? To just like,
that's crazy.
Every second you see a different picture. But I mean, it causes a lot of issues for them, because like there's a video on YouTube of one of these patients trying to pour like a cup of coffee. But obviously like the refresh rate essentially of her vision is so slow that she's not going to be able to tell
when it's full.
When it's full. So she overflows it every time, and she has to have like help and indicators on how to do that.
Wow.
And so there's some really interesting stuff like that. And also people, for example, like if you have an object like this, I don't know, I'm holding my phone now. And let's say we have like a mailbox slot, and I had to put my phone or like a letter into the mailbox slot. I would be able to do that because I can tell what the orientation of the slot is. Then I can do that with my hand. And there's people who can, one, see the mailbox slot, but then not put an object in it. Or two, they're like, I don't know what orientation the object is, but I can put something in it just fine. So that's really, really weird where that divergence is between like the object recognition part of it and then interacting with the object in that spatial awareness. So lots of really weird stuff there, but I like it. I think
and that's cool. Damage. That's because of damage to part of the brain.
Yeah. Yeah.
So can that happen on birth, or is that like an injury or
Yeah, all of the above, really. Birth is a big one. Stroke also. Strokes cause a lot of like blood clots, that kind of stuff. Even there's this one, I mean, brain trauma, like traumatic brain injury, TBI, is not something you see as often anymore. But there's a lot of research from like people, ages and ages ago in like the 1800s and whatnot, on their traumatic brain injuries. Like there's one really popular example, Phineas Gage, who was a coal mine worker, and he had like this metal rod while he was in a mining accident shoot up like through the base of his skull and out the top of his brain. So So like right through like his frontal regions, right through a lot of like the middle as well. And he survived. We don't know how he survived, miraculously, because he had like literally an entire pole through his skull. But because of that, after he survived and he recovered from that injury, a lot of his behavior was different. A lot of his emotional responses were different. A lot of his language capacities as well were really different. So because of that, we can now tell, like, you know, based on those injuries, okay, well, if this is where the injury was and this is the issue that he had afterwards, this is how his behavior changed. That's probably, you know, you can make those connections of that's probably what that's responsible for then.
So that would explain, like, when you have people who have accidents and they become someone different.
Yeah.
Because things have just been bashed around in there.
Yeah, especially if you have like a frontal issue, like a frontal control problem, because frontal is where a lot of like your how would you say it? Like the brakes are, essentially the brakes on your behavior, where your filter is. So if you're somebody who's very polite and well-mannered, for example, but then you have an injury to your frontal lobe that kind of damages the area that controls for that puts the brakes on those thoughts, you can end up being a much more like aggressive or violent person afterwards, which is strange. Yeah.
Yeah, you see that quite a lot, don't you? Like, so I know it's movies, but in a lot of movies, if it's ever brain damage, it's they get angry or and they change completely.
Yeah.
So the brain, so we're electric, right? We have, somehow we're not plugged into anything.
Nope.
But we're electric, and I think that's the way technology is going to go in the end. To be honest, I'm very scared for technology, but I think that's the way it's going to go. We won't need to plug in
technology.
We won't need to plug into anything soon. It'll just be like us. Because I see, why haven't we harnessed how us humans stay alive and put it into technology yet? I don't see, or someone has done that and they're just slowly releasing it, and we'll get it in a couple of years' time.
That's like light years ahead of where we are. That is so far out. If we tried to put our brain into like a computer form, if we tried to manufacture a human brain, like we don't even have the resources to build that yet, you know? It would take so much time, so much energy, but also just so much like storage space. We don't even have the capacities to begin to understand how to even do that. So the concept of us using that same technology, that's, you know, we can't even make what's in this small space with 1,000 computers. So how would we ever harness that, you know?
But my phone is cleverer than anyone I'll ever meet, because it can remember passwords that I won't remember. It can remember that I've been here 10 weeks ago. Oh, do you remember when you did this? No, well, actually I didn't, but you do. Like AI, it's already there, really. Like, that's cleverer than a human brain. All right.
That's the thing. That depends on what your definition of clever is. And this is very much like an ongoing debate in terms of AI, is like, what makes a human human? Like, what is it about us that we have that A, other animals don't have, and B, that technology currently doesn't have? You know, is it our ability to reason, to plan? Maybe not, if AI can do that. Is our ability to, for example, appreciate art, to categorize what is art and what isn't. On a lot of basic things, actually, it is quite difficult with AI to program a lot of things. Like, for example, if I asked you what a chair was, how would you define what like a chair is?
Me, you sit on it.
Yeah, you sit on it. So anything that you can sit on is a chair.
No.
Okay,
No.
so what's your boundary definition? Does it have to have 4 legs?
4 legs, yeah, 4 legs and a back.
What if you have a chair that says like a bar stool? Is that still a chair?
You just said it's a stool. It's only got 1 leg, it's not 4.
So a stool is not a chair? Okay.
Yeah.
What if you have like a chair that has like 2 outwards legs, like 2 long slats of wood?
Yeah, I get what you mean.
Yeah.
AI
so basically, we have so many of those concepts that are very much like we inherently understand and know what they are. But if you try to write rules for it, for an AI to understand what a chair is, they're going to get confused very quickly, right?
Yeah.
So that's one of the big issues.
Yeah. So going on to that, have you seen, obviously we're talking about electrodes. Have you seen this chip that Elon Musk is designing?
Neuralink.
Which
I can't say I know a lot about it, unfortunately.
No, which when you take away the things that could happen with it, the reason why he says he's designing it is which actually makes sense when you look at it simply, is that it can send new electrodes. So like people who lose the loss of movement in limbs, well, it can then fire up that pathway to make the arm move again, which make sense if it is like a bit of spinal damage or whatever that's basically crimping that electric cable, if you want to say it like that. So it makes sense. Do you think that the research you've done on the brain that will work, that could be done?
Yeah, it's difficult because again, there's so many different places where it can go wrong, right?
Yeah.
So if you're saying, like, for example, you have damage in a leg, it could be on your spinal cord where it's going wrong. It could be somewhere in the movement areas of your brain that it's going wrong. It could be anywhere. So to say you have like one chip in one place that's going to be a fix, I think it could happen for a select group of people, but in order to make it like generalizable for the entire population to fix like every single thing, every single neuromuscular disorder that we have, I think that's going to be really difficult. I think that's a big challenge, and I don't think we're there yet. Although, of course, I don't know what Elon Musk is up to in his laboratory, so maybe he's figured it out.
And very dangerous, I think, like, especially if you've got a lot of money, the things that you could, something you could do with that, like enhancing yourself, like medically enhancing yourself faster,
well, here's the thing,
faster, stronger.
Yeah.
It's like a modern day steroids. Just plug yourself into a computer like a car does. Oh, I want to be stronger, faster. Beep, 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 beep. Plug yourself in. Like,
I will say a lot of the comments that I get a lot, especially in psychology in general, is like, oh, you know, what you're doing is like manipulative, and it's all about like compliance and figuring out how to get people to do the stuff they don't want to do. And it's interesting because the master that I've taken, it's not as heavy on neuroscience as it is applying psychology and psychological principles in society. So for example, how can you change behavior? A lot of what we do is behavior change paradigms. Where we are essentially, that's our goal, is to change the way that you behave, is to take something that you do and put you in a situation where you change that behavior. And although that does sound kind of manipulative and working on a lot of compliance techniques and stuff like that, really a lot of the time it's for your benefit. For example, one of the things that we work on, we have a couple of different cases that we've looked at in the past. For example, if you have a train track and everybody just walks over the train track, over the crossing without looking left and right beforehand, which obviously is quite dangerous. One of the behavior change techniques that we could look at is, okay, what kind of gates could we put before the train tracks in order to make sure that you think twice before you walk onto them? Like, how can we stop you in your tracks? One of the ones I really like is, for example, I think this was actually in the UK with your subway system, or whatever you call it, what is it, subway, metro, underground? Underground, there we go.
Simple, just underground.
I mean, it is underground, so you're right. But one of the things they did there is they wanted people to be more motivated to take the stairs instead of going up the escalator. And instead of, you know, like blocking off the escalator or something like that, what they did is they put piano keys on the steps, so one piano key per step, and then they made it so that they were musical. So if you step on them, you make a noise. And then people would be driven to walk up the steps and to do a little dance to try and play a little song as they walked up the steps. So that is behavior change, right? That is manipulation.
Yeah.
But it's not with this really strong ill intent. And I think a lot of times psychology gets a bit of a bad rep for, you know, you're trying to make us do this and the government is controlling us. But really, a lot of it is for our own benefit and to make life a little bit more fun.
You're always going to get that. Me and you have our back and forths about conspiracies and blah. And I do a lot. I do a lot of it just because I like a good conversation. And I love that when I do it with my partner too, you just drop a bomb in there and you can get so much information from them. And that's a great conversation. But as humans, is it the brain again? Are we programmed to ask questions and not to rebel, but to always question something? Are we programmed to do that? Or is that just a type of person that does that?
That could be a contender for, like, you know, what makes us human, what makes us different from other animals is our inherent curiosity and our desire to look beyond what we have now. Evolutionarily speaking, there's a couple different reasons why we might have this curiosity. Like if you look at different types of apes, like gorillas and stuff like that, the amount of time that they spend in a day looking for food is like, I think, I'm not sure, don't quote me on this, but gorillas, it's like 15 hours a day or something that they spend purely foraging food and trying to consume it. And when you look at the different day-to-day behavior patterns in animals, they have so much that is based around survival that we don't actually know whether they have, you know, if because they don't have time to think about anything else. Whereas with humans, we've managed to figure out how to take care of all our basic needs. We've managed to figure that out thousands and thousands of years ago when, you know, use of technology, transformative technology like fire, building shelter, working together, working, culture, developing ways of communicating with each other. So because of that, we've been able to
supermarkets.
We've been able to make that step and say, okay, well, I'm just going to buy dinner, and after 15 minutes I will have eaten, and then I'll be set. So what do I do for the other 14 hours in my day,
Yeah.
So that's how we think we ended up with things like curiosity, is because we just had so much time on our hands and we made things so efficient. What else are you going to do?
Yeah.
So
what is a thought? You mentioned it earlier. You dropped that in there. I was going to ask it anyway, but what is a thought?
This is like the question of like, what is the mind? We don't know. God, we don't know. I can tell you that a thought is like a connection of different signals and a neural activation or something like that. But none of those answers are going to satisfy your need to know what a thought is it?
They're not at all.
Yeah, it's not something we genuinely really have an answer to yet in a way that we know. Very much sometimes we talk about like the black box of cognition, of how there's kind of still this blank space of like, okay, well, we see that this is happening, but we don't know if there is something else happening that either we don't know about or we don't fully understand yet. A lot of times in terms of science, we take the approach of physicalism. So we assume that everything that we can see is what there is, so that, all of our thoughts and our goals and our, desires come from our brain. But there's also other ways of looking at it where you're like, okay, well, maybe there's something else to it. Maybe the mind is somewhere a bit more spiritual, you get those different directions. And in all honesty, although of course I've been brought up as very much a physicalist and I'm not the most spiritual of people there, sometimes when you do research, it is difficult to think that, everything really is just here. All of it is just here. Yeah.
So a thought process, surely you've looked up how a thought process works or reacts when someone has a thought. What happens does it just come from nowhere and then it's electrodes and all that stuff going everywhere and neurons, or is there something else that happens before a thought or as a thought's happening? Like, what actually happens?
Yeah, so I think one of the interesting ways to look at this is through EEG. Do you know how EEG works roughly? It's the electroencephalogram.
Is that like when all the stuff on your heads?
Like yeah, with the different electrodes
on your heads.
On
your heads? Why someone got two heads? Like, that would definitely be someone for science. Yeah, so yeah, like when they put all the stick, all the stuff. Yeah.
Yeah, and sometimes they use like the gel to get it to go on your head, and sometimes they don't. I prefer it when they don't. So basically, what you can see with that is EEG is really good in terms of time, in terms of temporal resolution. So we can see not necessarily exactly what happens, but we can see exactly when it happens, which is really helpful. And then we have different kind of components that always show up within EEG. One of them, for example, is a P300, what we would call. So that's 300 milliseconds after you see something or notice something or your attention shifts, that you have this kind of wave of activity through your brain. And that can be specific to different regions of the brain as well, depending on what kind of input it is. So that's one way to look at what our thought process is like these different waves at certain time points after we encounter something or we have attention and change our attention patterns towards something. And there's also, like, for example, a lot of oddball tasks and change detection tasks, where if you're seeing something or listening to something and something is different than what you expect, then you also have different components like the N400. So the N400 is like a negative at 400 milliseconds after you experience something that's out of place. So let's say you're listening to like tap, 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 and then there's one missing. That would be a moment of, oh, N400, something is out of place, something is wrong. And it's interesting because these are things that you can notice also in infants. So we know that it's really something that's ingrained into us because it's something you can detect from a very young age.
So why do people think differently? Like, I know we say it's a background this, background that, but why would you react to something different that I would react to it? Or why is that a thing?
I think this is getting a little bit into the nature and nurture debate, right? Like, is the way that you think and you react to stuff, is that part of something that you inherited with your genetics, or is it part of something that you learned as you grew up? It's both. It's 50-50. I think it's very much so that when you are born, you have certain predispositions to different types of behavior and to different types of reactions. But then as you grow, the way that you have been nurtured, that is basically what makes sure that either you display those behaviors or you don't. So it is a bit of a complex network of, okay, well, these are the behaviors that my parents showed throughout their lives, and that, you know, the rest of my family showed, which you inherited then, but also, like, you know, what do people at school use to react? How do the people around you, what kind of media do you consume? Everything has an impact. There's nothing that kind of doesn't have some kind of effect on the brain, which makes it really difficult to study. But also it makes us really complex, and it means that we can, you know, have lots of different motivations and reasoning, which is for us really good. It means we have the capacity to learn and change.
And do everybody have different sizes of different bits? You've got the 4 bits. Has everyone got different sizes or different strengths? So like some people can deal more with depression, or they can deal more. Some people are more angry just naturally. And let's say it's not a background issue. Let's say it's a brain issue. Is there different sizes and different strengths?
Well, yes and no. Yes and no in the sense of, for no, a lot of people are born with different brain sizes, or, you know, like the same way we have different heights, and that doesn't really affect it too much. What we have seen is there was a study of taxi drivers in London and their hippocampus, so part of the space where they store memory, particularly for like spatial memory, and they tracked the density of the area of the brain that was related to mapping out like space, so awareness of space. And for these taxi drivers, who obviously are driving around every single day, their spatial awareness of the region that they were in, that awareness is really high. So because of that, the density of the part of their brain where they stored that information was also really high. And they tracked like new and training taxi drivers who would, like, at the start when they just started versus when they've been training for months and months. And they saw that that density increased over time. So that's something.
So you can train it like a muscle.
Yeah, almost. Yeah. For a lot of things you can.
Which obviously that's why we do a lot of, I don't know, like when people are against school and stuff. I know there's something at school I would be against, but like our reading, writing and stuff like that, we can work on that and we can get better at it.
Yeah, that's actually an interesting one as well. I like language in general, but reading and writing is not something that we are born with. Reading and writing is 100% a learned thing. So speech is something we are born with. We're born with the capacity to speak. We learn language naturally in the spoken form. Almost everybody just speaks, you know, there's nobody in the world who doesn't speak a language, right?
Yeah.
Like, have you ever met someone that isn't able to speak to you? No. So what we do see a lot is that reading and writing, because it's something that's cultural and that's something that we teach, you don't naturally pick it up, right? You don't have this, you don't wake up as a baby and go like, okay, well, I'm going to write now. No, you babble.
Yeah.
You have those language sounds, your vocal sounds, but you don't have the reading and writing in there because that's visual.
Yeah.
So that's something that like is taught in schools. And because of that, we see a lot more kind of like deficiencies and issues with reading and writing, because that's not something that's innate to us. That's something that's culturally taught, which I think is really interesting as well.
Yeah, well, that makes complete sense, because for me, I hated school apart from my drama and art. I couldn't stand things where I was writing, and if I did write, I was excited to write a story that I would not care about spelling, about how well I was writing. I wanted to just get everything from my head down on paper, and just that little paragraph there probably explains me as a person, and people who know me will go, oh yeah, that pretty makes sense. So then spelling for me was very hard and still is very hard, but since I've left it and I've needed it in adult life, I've got better at it. And surely that's just like, I don't know, bicep curling or weight. It's the same sort of thing. You're teaching that muscle to be better at something.
Yeah.
Is that correct?
So for sure.
So you can work on stuff like that. It just takes time to work on it. So the people who struggle with stuff like that, is that because they've got naturally from birth, a weaker part of that brain, or is that just?
It could be 100 different things. You know, they could have something like dyslexia, dyscalculia. I don't know. I never know how to pronounce that one. The one with numbers, basically, dyslexia for numbers. Or they could have some kind of internal damage, like from birth, congenital birth defects, damage to their brain. A lot of what we see with language, especially, is lateralized on the left side of our brain. Sorry, I don't know what left and right is. So this side of the brain. So a lot of times if you have some kind of issue with especially your frontal temporal regions in the left side of the brain, that's going to be to do with language. So it could be an issue there. It could also just be that there's nothing physically wrong with you, but you just have a hard time picking up certain things, and you have an easier time picking up certain other things. You know, like the academic system is trained towards a very specific kind of skill set, right? And not everybody is going to be good at learning that specific kind of skill set. And I think it's a little bit unfortunate that these days in education, we tend to reward certain types of capacities for learning more than other types of capacities for learning. I mean, it is what it is, unfortunately, but it's one of those things where academic smarts is not necessarily the whole picture, right? Like, for example, if you look at an intelligence test, a lot of times, like with the Raven intelligence test, which is a pretty common one that's used, even though we don't really know what intelligence is, that's also one of those big abstract concepts. But the Raven intelligence test is based on pattern detection and being able to essentially solve puzzles. So very much visual puzzles, but those are things that you don't need like reading and writing for.
Yeah.
And we use those to determine intelligence. So, yeah.
So it's not like how good you are at mathematics or how good you are at spelling. They look at it as something different, like you say, pattern detection.
Yeah, the Raven intelligence test does in particular. So they'll give you, for example, there's ones you can take online for free, by the way. This is something you can do at home, where they give you like 3 different shapes, and then you have to pick out of a series of shapes what the next one in the sequence would be. So that's a way that they kind of, you know, through pattern detection recognition, how quickly you catch on to what the pattern is between the shapes. That's what they then use to gauge your intelligence. Yeah.
So going on to that, why do you think, now you might completely disagree with me, but why do you think probably 99% of very intelligent people, I'm not talking about you here, I might be, but intelligent people sometimes find social situations awkward?
Okay, that is an interesting. You said that we would disagree, so I'm kind of curious to know what you think first of all.
So is it something to do with the brain? So do you know, like, I'm not very clever in the way I would see you as clever, but I am very out there in a social situation, and, well, do you know what I mean? The way I am, whereas you could be very closed, or sometimes you just say it how you see it. Do you know what I mean? Like, or some people would just say it. Very intelligent people sometimes can come across as, and this is not all,
Socially awkward.
yeah, not always towards you, but I'm just thinking back to the people at school that you think about who were really clever, where some people who were normally sometimes maybe on their own or didn't have very many friends, and this is not like thinking about, oh, well, they were bullied, but just thinking about the very clever people who I now know are like, oh my God, that's amazing how clever you are. They all seem to be not the same, but in that same sort of category as they struggle in social situations.
Yeah, so this is getting a bit more into like sociology, psychology, probably a little bit further away from neuroscience, but a lot of it is to do, or at least I would expect, with things like self-esteem. Like, I know, for example, when I was growing up, because I was always somebody who was good at academics, it's just, you know, it's just the way that I was. But because of that, I always kind of got a green card for everything else. Like, I was never expected to look a certain way or to fit in with a certain social group, because I was like, oh, well, you're smart, you know, that's fine, that's enough. So if you have that one thing, then sometimes all of the attention goes there. And especially if that's the thing that if you're academically smart and you're getting your praise from teachers for that, you're getting praise from your parents for that, and nobody pays too much attention to your social interaction because they're praising you for this other thing that you can do, then just less time and energy is going to be spent on that. So I definitely think that, you know, if something like academics is not your strong suit, and you end up spending a lot of time instead trying to figure out how to interact with other people, or how to, you know, like be funny or come across a certain way, then that's going to be something that you end up being better at. So it's where you put your time and your energy, and it's where other people reward you as well.
Yeah, so it's like training that certain part of the brain instead of the other part of the brain, and then it makes those situations very difficult. If you know what I mean. Yeah. Like, because you find sometimes quite a lot of smart people, they'll say something and they don't mean it that way, but it will just come across in a certain way because they're like, that's just the way they know, well, I'm going to tell you that you're stupid, or I'm going to tell you you fully got that wrong, or I'm right. Whereas, like, I wouldn't want the conflict, so it'd be a bit like, yeah, I think maybe, yeah, kind of, sort of, I think you might be wrong about that. I think, I'm not sure, I think. Where you'd be like, you're wrong. And that person would be like, oh, all right, okay. But I'm just thinking,
a lot of that is like society and culture as well, you know, like we're not in like a meritocracy, but we are very much in a society that highly values academics.
Yeah.
And because that, if you are smart, then your opinion is like already valued as up. Like, you're put on a pedestal a little bit because you're like, oh, they know what they're talking about.
Yeah.
So you can get away with it.
Get away with it.
Yeah. Which is, it's strange. And I don't think it's always right, but it is something you see a lot. Yeah. And I've experienced that as well from, you know, other people within the university and that kind of stuff.
So that's more of a behavior thing than it is an actual brain thing. Or,
I mean, everything ultimately is a brain thing,
it's a
but this is
brain thing.
something we know
Yeah.
more about from the perspective of behavior. Yeah.
Yeah. So let's dive into like what depression and stuff like that is. Is that down to bad thoughts, or is that down to something going on in the brain which is causing the depression? And something that's very high, mental illness is very big in this day and age, definitely in 2020, the year that we all want to disappear. In 2020, like, is it something that we do to ourselves, or is it something that the brain is not doing to us, but is it like the size are you more susceptible to depression if you've got one part of your brain stronger than the other? Or that's what I'm
Yeah,
trying to
so
say.
depression is a brain thing, anxiety is a brain thing, all of them, it's all brain stuff. It's all with the amount of, neurotransmitters that you have available in your brains. Also the different circuits that are, activated more often than others, like, for example, trauma or something like that can make sure, we talked about these fear regions before, can overstimulate those. You can also be more susceptible to things like anxiety and depression based on your genetics. So if you have, like, for example, schizophrenia is something that's very strongly, or at least it's not schizophrenia anymore, DID, is very strongly linked to
What's
genetics.
the
So
ID?
dissociative identity disorder.
Oh, okay. So yeah, that sounds a lot nicer than schizophrenia.
Yeah, it's a little bit more all-encompassing than schizophrenia. So it's kind of all aspects of the dissociating away from your own personality, as opposed to just having multiple personalities in one body, because
Yeah.
that's a very extreme and not very common form. But yeah, so it's all brain stuff. All of it is brain stuff. But just because it's a brain thing doesn't mean that we don't have any influence over it, right? Because a lot of how our brain is very plastic. So we talk about neuroplasticity a lot, which is the ability of our brain to grow and to learn and to change, and like for the literal neurons in our brain to either develop and grow or move around and become parts of different networks, or to become underused and to not fire at all, or to have like a higher or lower threshold. All of that is influenced by what we do and what we see and what we experience. So even though depression is something that you can very much see in the brain and detect and find in the brain, it's also something that the brain is malleable, essentially. So that we can put ourselves in positions where we are more susceptible or less susceptible to depression.
What does depression look like?
Yeah, that's a difficult one. It depends. One of the things that they use to treat depression is SSRI, so serotonin reuptake inhibitors or something like that, where you have a lack of serotonin in your brain. So you need more of it in order to feel at the same kind of level. Do you know how like addiction works with neurotransmitters in your brain?
You go into it. I'll
Okay.
butcher it. I'll massively butcher it. So you go into it.
I think everybody kind of has a general understanding of how it works, right? So like with your brain, with your neurons, you have a certain number. Let's say you have like 10 neurotransmitter molecules in your brain normally, and that like gets you through a day and you're fine. And then when you have a substance, like let's say you do some form of drug that emits more neurotransmitters, or that either causes more neurotransmitters to be released, stops neurotransmitters from being cleared out of the way, because usually after they're released, after a certain period of time, they're cleared out again and they're taken back up into the neuron. Or it like blocks the receptors. In either way, usually when you take a drug, there will be more of a certain neurotransmitter available. But because there's more available, your brain will then adapt to that. So your brain will say, oh, there's too much here. And that's what causes the high. But our brain also says, like, that's not right. We need to change that. So let's say, for example, that there's too many neurotransmitters being released, then your brain will say, okay, we should probably release less. So then the next time that you take it, that's how your tolerance builds up. You have to take more of the drug in order for more of the neurotransmitters to be released for you to feel that same effect. And because of that, the first time that you take a drug is probably going to be the highest that your high will ever be, because after that, your brain starts to adjust to it. And sometimes it even gets to a point, like I think caffeine's a bad example, but I think it's the most relatable example.
Hey, don't you dare talk bad about caffeine.
Where it gets to
The
a point
power
where
of this show.
Oh, it really is. Coffee with Sam. But it gets to a point where you cannot function like a normal human without having taken your caffeine boost.
Yeah, I've seen that thing with the spider as well. The spider who has caffeine and it tries to do a web and it's like, woo! And I'm like, yeah, that's me.
I love those. Those random little studies with like spiders and like rats and whatnot with drugs. They're always, I don't understand them, but I think they're fascinating.
But you say you get to that point where you can't function without it because those neurons aren't being released. Is that what you're saying?
The neurotransmitters, yeah. So those substances are either, well, your brain is just saying, well, because we're getting a steady influx of this, we have to adapt to our environment, and now I need to release less neurotransmitters because they're expecting the drug to come in. And with depression, one of the things that you can see, for example, with serotonin is that your serotonin levels are just lower than they should be. And the thing is, with medication for that, so with SSRIs, you are adding serotonin to the system. So the reuptake inhibitors, they stop the serotonin from being cleared away after a while. But that's not fixing the problem, right? That's just treating the symptoms.
Yeah.
I think that's the biggest issue with a lot of like the pharmaceutical side of the medications that we have for depression, is that they're treating symptoms as opposed to the cause, because we don't always know the cause, and we don't always know how to fix the cause, even if we know where it is in the brain. So.
Yeah, that's a whole new can of worms, and another can of worms going into the pharmaceutical industry. But so yeah, and with the job I've been involved in, I always used to say that, like, I'm not a doctor, but if we can get you off these tablets, I know they're going to make you worse, because I've known many people actually get worse on it, and that completely makes sense, that you're not fixing it. So when they try and wean off them, or they take a few less, they just feel crap again. And it's because their body doesn't know how to deal with that. And that makes complete sense.
Yeah.
But like you say, if you then put it on the other side, that they don't actually know the problem, so they can't help, then you have to say, okay, you're trying your hardest. You're doing your best. But that's crazy to talk about drugs in that way, because it's not actually, you don't get addicted to it. Your body does.
Yeah, your body expects it to happen again and just adjusts for it because of it.
Because you say to people, like, you're addicted to drugs, or I'm addicted to caffeine, or I'm addicted to alcohol, or you're addicted to this, you're addicted to that. And you are, because you are your brain, but it's actually your brain taking over you as such. Mm-hmm. Saying, like, full well we shouldn't be having this, but you give it me, and now I can't perform how I want to perform. Take it again. That's crazy.
Exactly. Yeah, it's like when you talk about like why it's so hard to quit smoking cigarettes, something like that. It's because of that. It's because consciously you can fully understand and know what the downsides are, but that doesn't change the fact that your body's used to it and that your body might need it to function. So that's what makes it difficult.
That's incredible.
That's also why addiction is considered really to be like a mental health issue and to be like an actual disorder as opposed to just like a thing.
Well, yeah, because when you actually think about it, we are the brain. The brain has now got a problem, and that is then a disorder, right? It's the word disorder means this out of order, right? Kind of things out of order, and that's a great way to put it, and a great way to look at it. So, like, for people for PTs, for any type of trainer, any coach who I'm not a doctor, I can't help you, but they start to understand things like this, I'm now going to think completely differently, because I've never even thought about it that way. I've never really looked into addiction. I've never looked into what addiction is. But that's a great simple way to put it for people to understand it. And then as soon as you say that, it's the same as a conversation I had with someone on here who he had depression, and he started to have suicidal thoughts, and he's now he wants to help other people. And that's now his life goal, is to put himself into so much, to get courses and to become looking after people's mental health. And he put it that when people have suicidal thoughts, they are not them. They are someone else. They are completely someone else. So that person thinks, well, this is a great thing to kill myself, because that they see that as the good thing, not as surviving. Whereas the person, if they were the person who they used to be, that person would see, well, I've got family, I've got friends, I need to stay alive. And that, to me, now I know how to approach a situation a lot easier, put in that way. Now, the same way you've just put that, I'll be able to approach someone who's got an alcohol addiction, or a drug addiction, or addiction to something, in a complete different way, because you can be a bit more sympathetic.
Yeah.
Because you're like, okay, it's their brain that needs this. How can we now, not the word wean, but how can we now cut that back to the brain start to function properly, not just you're addicted to it and you want that type thing. Because at the end of a drug addiction or alcohol addiction, they don't really want the positive benefits from it, because there is no positives. Once they get that deep into an addiction, there's not really positives from it, because they look horrendous, their body's shutting down, And like you say, it's just their body saying, I want to feel okay, let's take some more. So that's an amazing way to put it. So I've learned something today, so I hope people listening and watching have learned something.
That's one thing. It is difficult though, because the addiction is never just the substance, right? And especially when you see, for example, with smoking, a lot of smoking addictions are also bent on the fact that when people smoke, they get to take 5 minutes out of their workday to just stand outside and like de-stress and socialize with other people. So you get so deep into these habits that are fundamentally grounded in the fact that your brain needs it in order to feel alive. But then also you build up so many structures around it. So that's why when you're dealing with things like, it's the same thing for depression, but like in different situations, when you're dealing with these kinds of things, it's oftentimes a combination of like that pharmaceutical side of it, like what the chemicals in your brains are doing and how do you rebalance those chemicals, but then also how do you get out of these patterns and structures that you've built up for yourself in your life to enable this to go on.
That's probably the last thing you want to do, is start taking away the drugs first, fix the habits around it. Now I know that straight away. When I used to be a mechanic, every morning I'd have to have a can of Monster or Relentless driving to work, because it felt weird if I didn't. So on mornings where I'd just be late and I'd drive straight to work, I would feel like I missed something, and it wasn't the caffeine I was missing. So then I would be like, when's the lunch truck coming? Because I can then get my can. And it wasn't the fact of, the caffeine. It was that I'd missed the driving to work with that caffeine, with the can in my hand that I would normally have every morning. So it was the habits around the addiction, and it was that I had to stop. And then I didn't like, I need caffeine now, I need no caffeine. It was getting over that weird feeling of just driving to work. And the habits around it. So that's another great thing for people who are trying to, with mental, if they've got any problems going on, not just with addiction, but if they're feeling depressed and stuff, don't go straight to taking everything away. Start to take away the habits away, because then the brain will then obviously start to find that a little bit easier to then take away the main bit, which is the actual problem.
Yeah, like pulling that back to the depression as well. One of the things that I really liked, it's more of like a pop culture kind of therapist talk as opposed to like brain really specific. But a lot of the times we build up these habits and these structures to kind of end up feeling like a chore as well. So for depressed people, a lot of times, sometimes you'll be lying in bed and you'll be like, I just cannot get out of bed. I just cannot get up, or I cannot go and like make myself food. It's just so much effort, and it feels like so much effort for no payoff at all. But then to break that down into these like smaller steps of like, well, if I want to eat a sandwich, I don't have to eat the entire sandwich. I can just eat the bits and pieces of it. Like I can just eat some bread, and then I can have some lettuce and some ham, and that can just be it, A lot of these societal constructs almost of like what we expect like a family meal to be like at the end of the day, or how we expect a work day to look. It's not always beneficial for us. Structure and routine is good, and habits can be really good, but we adapt to habits really quickly. Sometimes like it's scary how fast it goes from, like, for example, you might have noticed if you've ever gotten like a new achievement, or like moved into a new space, or like moved to a new school or university, how quickly it takes for that newness to wear off and for it to just feel normal. Yeah. And then you go back and you look on like your recent place and you're like, this doesn't feel normal. We're so fast at adapting to those new scenarios. And we're so also emotionally invested in the present time. Jumping a little bit to a different topic here, but one thing I also like that find quite interesting about how we perceive emotions is that emotions actually skew the way that we view time. So when we have a really strong emotion, we think that emotion is going to last a long time. Whereas if we have like a weaker emotion, we think it's going to last a shorter period of time. But a lot of times, especially with anger, but also with like these feelings of joy, when we feel happy, we feel like we're going to be happy forever. We feel like we've made it, that something great has happened. But then when we get to the next day and it's kind of worn off, like it goes away quite quickly. So when you're in like a hyper emotional state, you'll often think that the way you're feeling now is the way you're going to be feeling for a lot longer than you end up feeling it. So I think with depression as well, it can feel like you're just kind of in the middle of this pit that will never end. But that's because the feelings that you have at that point, they feel, or sometimes the lack of feelings even, sometimes you just feel kind of so dead and like totally zoned out that you just feel like that is how it's going to be forever, because that experience is so intense at the time. When in reality, it could actually only just be you habituating to the situation that you're in. One interesting thing about depression too is appraisal. I don't know if you know anything about cognitive appraisal, but for a healthy person, we're actually quite egotistic in terms of appraisal. So if something good happens, we'll attribute it to ourselves. And if something bad happens, like if I'm late for something, I'll attribute it to something else. Like let's say I'm on my way to work and I come on time early to work. I'll be like, oh, well, that's me and my good time management. But if I'm late to work, I'll be like, oh, well, I was stuck in traffic, you know? And depressed people, it's the opposite a lot of times. So depressed people, if something good happens to them, they'll be like, that's because of something else, you know? That like, that's not because of me. This just kind of fell in my lap, or this just happened to happen to me.
Yeah.
Whereas with like the negative stuff, like if they're late, they're like, oh my God, it's because I'm such a terrible person, you know? It's interesting to see how those normal behaviors flip.
And that makes sense again. Like when you keep talking, I keep seeing behaviors I've seen in the past, and I've seen that. I've seen people be like that, and I've seen, or when I was feeling at that time, I've said things like that, like, "Oh my God, it was my fault," or someone else has done something, and you put yourself at blame for it. And then I think back to actually how I felt. Well, actually, I was down at that time, or so that makes so much sense. So much sense. And like I said, you've seen people do that, or types of people that do that. And then you see where they've gone on to go to, and you think, okay, well, that's actually a sign of where they were going, good or bad.
Yeah, and you can see how quickly it can become dangerous, especially in like, for example, in a case of domestic abuse. If you become slowly more and more depressed because you're in an abusive relationship, but then you also start to attribute bad things that happen to yourself, you're going to be thinking, oh, well, I probably deserved that. You know, I probably deserved whatever happened, or I'm overthinking it, or it's, you know, it's me.
Yeah.
So because of that, you're actually ending up in a cycle of making yourself feel worse, but then also feeling like it's your own fault, so you should stay. As opposed to like a normal healthy person who encounters domestic abuse will be like, well, I didn't deserve to just get hit in the face. You know, I'm going to go and do something about it. I'm going to leave this person. Somebody who's in a cycle of abuse and who's developing those depressive symptoms and mindsets as well is going to get stuck in there, which makes it really difficult for them to leave as well, because they don't think that they think that it's their fault a lot of the time.
And then when people approach them, they defend the person who's abusing them. Yeah, and
They're not always like this.
Yeah, and that makes sense. Don't do it. Don't hit people. Don't abuse people.
PSA, domestic violence, bad.
That's my message.
We know the rates have gone up during COVID of domestic abuse, which is very bad since everybody is staying at home. So be safe.
Yeah, and I think that could be one, not defending people, one, from that it was already happening anyway, and two, people really struggling and taking it out on other people, because I was in a cycle of that, and I was snapping, and I was taking it out on my partner, I was taking it out on Alex, and I was snapping. It was because I hadn't spoken to anyone about how I felt. I hadn't told no one how much I was being me, and like, yeah, losing my career is fine. Haha, yeah, I'll go get another job because I'm so good at that. And I hate this job, but I'm going to do it for the good of us and the good of our house. And yeah, and I was doing all that. But then I didn't see myself snapping and taking what I wasn't talking about out on someone else until the day I burst out crying and was like, this isn't me, and said, I'm not okay. And then we spoke about it. And then I was like, woo, drove to work that day. Like, I feel great. Everything I saw back from weeks and weeks where it had just been getting worse and worse and worse. And then Alex could see where it was coming from. She saw the behavior, and then we were okay. But so I can see a lot of people like the domestic abuse has gone up in 2020, but I can also see it could be one, that's the way it was before, and it's just been heightened, or two, there's some people stuck in a lot of situations that they were never ready for. Like I wasn't ready for this.
Yeah, for sure.
And some people can say they were ready or they weren't ready. We weren't ready for the height of it, but I just 100% wasn't ready emotionally. Just wasn't ready for what was good to happen. And then that, because it was so fast, my train of thought and thinking just went out the window. And then because I had all this anger wherever we keep it in our brain, I kept this anger all in and didn't let it shine. It was just making all my other, well, no, was it the blood? Was the blood going to my anger, my fear part? Was that where it was going? And then it was making me I was thinking irrationally, and I was acting irrationally. Well, look at me talking all science. Oh, hi there. I'm gonna wear a white coat next time I come on here. Changing. We're not allowed to drink coffee on here anymore because that's addictive. Apparently, it's gonna be the Water with Sam podcast, and we're gonna talk science.
Water with Sam. You could do like orange juice with Sam. It doesn't have to be water.
Sugar. What about sugar? The effects of sugar on the brain. So I was gonna cut it right there, but a topic which is real big in the news at the moment is concussion. Do you have any background or any thoughts on concussion? And
Definitely had a concussion before.
Yep, I've had one of those too. And do you think definitely in sports, it's something we're just going to have to learn to deal with? Because it's this week, the rugby are going into it. Obviously, I know we had the big scandal with the NFL and that one doctor trying to say that it was causing people to kill themselves and causing onset dementia and Alzheimer's. And the NFL tried to hit him out and get rid of him because of what he was saying. Obviously, because multi-billion-dollar would have been ended. We did get positives with the NFL because they stopped the head-on-head collisions and going in recklessly. But now with rugby, it's come up massive, and you've got rugby players now trying to sue certain people because of, oh no, there's one England player who couldn't actually remember playing the World Cup and winning the World Cup, and he can't remember it to this day, winning the World Cup.
Jesus. Yeah. Wow.
Do you think it's ever going to disappear from sport? 'Cause it's coming into football too. They're trying to say that heading the ball causes Alzheimer's. The way I can see it is you stop heading of the ball and you stop playing rugby. What is a concussion? And like, is it as easy as saying that something's just soft head hit to the head, or is it something that has to come from constant heavy impact?
Yeah, it's difficult to say because I don't know exactly what the terminology for concussion would encompass. Like, I don't know what would exactly count as one and what wouldn't. But the things that it can cause can be really concerning. So for example, let's say you have a concussion. It usually, from my understanding, it means that your brain like shakes in the skull, like it moves in the place where it is. So you have your brain, and then you have like your 3 layers of tissues around the brain, and then you have your skull. And your brain is essentially like floating in liquid. It's like you know how you see like brains in jars sometimes? It's kind of like that, but with like tissue around it in your brain. But when that brain moves, like when it gets a really big hit and it moves, that can be really dangerous, or it can lead to a lot of things that are quite dangerous. The only issue is I don't think we're ever going to be in a scenario where we can entirely stop it. You know, with sports, sometimes you get like parents who are really like overprotective almost of their athletes. I don't think you're ever going to get to a point where you can have a sport that will be totally injury free. When it comes to things like professional boxing and fighting, that's where we've seen a lot of, where we've done a lot of research and where we've seen a lot of detrimental effects. But that's from like competitive boxing, so really being hit in the head over and over and over again, which I imagine would be somewhat applicable to sports like rugby as well, those really hard, heavy contact sports. But for sports in general, for something like a soccer ball hitting your head, I'm not sure, like unless you're getting hit with a soccer ball every single day. We probably don't have enough research on how that works because we're only now starting to really kick up a fuss about it. And B, any injuries that we have, it's difficult to link it to long-term effects. Like it's difficult to like one single injury or one set of injury to something that happens, like, because Alzheimer's develops a lot later on in life, right? So it's hard to make those long-term association connections. It's hard to study as well. It's hard to do research on it. So I don't know I think it's a good measure to take. I think it's obviously if we're doing a lot of like contact sports that involve your brain, you've got to be really careful about it. Same with like your spinal cord. But to the point where you would stop playing soccer forever, or football, soccer, I don't know what you call it. Yeah, that's debatable. That's debatable. And to really have hard concrete proof that like a soccer ball hitting your head X number of times is going to give you early onset Alzheimer's, that's also, I don't think that's something that's ever going to happen.
Okay. So for our UFC and our fight fans on here, what happens to the brain when they get knocked out? Why do you go out cold? Why does your body just disappear and
In all honesty, I don't know exactly what happens when you get entirely knocked out, because it's your like your consciousness that you lose, right? So your grip on consciousness, and that's something that we can induce with things like anesthesia as well. So I'm guessing that it's going to be sections, especially like more frontal sections, that just temporarily like the activation stops. But obviously not for long enough that the blood drains away and it's no longer receiving any oxygen. So, but obviously it's not going to be your entire brain, right? Because your functions, your heart rate, all of that kind of stuff is still going to be intact. So it's going to be a partial kind of a block, essentially, so that your activation stops in a small part of your brain for a small period of time.
So it's what we were saying at the beginning, because the bits that make you fight on the outside, and then the bits that keep you alive are on the inside. So it's the ones on the outside that just say, whoa, that was a big, the sponge inside's banged around against the skull, and they're like, nah, like lights out. Like lights out. That's
I would have to look into that a little bit more, because I think I'm probably oversimplifying it quite a bit, but that could essentially be what it is. Yeah.
Because sometimes is it that it's like an effect on the because they've been hit, it's their neck, which then their spinal cord, their brain's saying, oh, that was some stress on the spinal cord.
Your brain has the ability to shut itself down as well if it thinks you're in danger. So if you are, like, for example, if you have hypothermia or something like that, it'll get to a point where your brain is like, okay, we're going to conserve energy. So all of your conscious experience, we're going to shut that off for a minute because we need that energy elsewhere. So that could also be a thing if it's an injury somewhere else that your brain senses that you're in danger because of, that it just shuts down. Yeah.
Sorry, I literally just disappeared then and thought about running away from a lion, but your brain goes, no, we're in danger, and just shuts down. You're like, no. Wrong time to shut down. And you're just like,
Well, some people have like the freeze response, right? Like the start, like the deer in the headlights response.
Yeah.
So when you're presented with danger, that you freeze, which arguably is going to be worse, right?
Yeah, the same sort of thing.
You don't run, you don't go anywhere, you just stand there. It's probably good for snakes and stuff who rely on motion detection to find their prey, but in modern society, probably not as helpful.
Yeah, not the best thing to do. Awesome. That feels like a good point to stop there. That was well good. Loved it. You like educated a Muppet like me, so hopefully you educated a lot of the listeners. Thank you for
somebody got to take something away from this.
Thank you, me. Thank you for finally getting you on here. Thank you.
Okay, bye.
Peace. Love you. Bye-bye. We are back. Welcome to the Coffee with Sam podcast, guys. The spin-off show. Three's a party with my boys, the MMA guys. 0 wins. Terry, no chin, Brown.
Wait a minute. Who are you?
Get off.
Standing at a staggering 6'2.5" inches.
Wow.
In the heavyweight class.
Wow.
So he is my protector, guardian of my galaxy. Jeez, guys, you think he owned the podcast? Neil, Adam, we're live, by the way. Three's a party.